Почнуваме, добре дојдовте на првиот InTechX meetup. Моето име е Ана и вечерва заедно со овие тројца лепотани од мојата лева страна, кои што во моментов немаат поим што зборувам за нив, ќе бидеме со вас вечерва во следните отприлика 3 часа. Овој пат InTechX, бидејќи ќе имаме малку поинакво искуство, благодарение на тимот експерти од Massive Interactive, лидерот во светот на видео платформите. Се надевам дека сите до еден, овдека што сте присутни, ќе заминете со нови знаења, а најмногу од се ви посакувам да заминете со нови идеи. Бидејќи презентациите, како и дискусијата која што ќе следи на крајот на истите, ќе се одвива на англиски јазик, јас во моментов ќе се префрлам на англиска поддршка. Good evening everyone and welcome to the first ever InTechX meetup. Woo! Why InTechX? Well, simply because this time around we decided to do something different, something that goes a bit out of the ordinary concept of our previous InTech meetups, but still remains in the same spirit as before. Tonight, InTechX meets Massive Interactive and gives you a unique opportunity to get inside the minds of their finest, I guess, and to learn about their success story. Who is Massive Interactive anyway? Well, they're the company for delivering worldwide video entertainment experiences with headquarters in London and with offices in New York, Prague, Sydney, and you guessed it, now in Skopje too. And this is how we're gonna roll tonight. We have 3 speakers, as you can see. And while they are presenting, if at any point in time you want to join in this discussion and you don't want to forget the question you have in mind, you can simply share it at our hashtag InTechX on social media, and we will answer all of your questions at the end when we will have a Q&A session. Before we move on to the presentation, let's not forget our supporters without whom this tonight would not have been possible. Please give a round of applause for Sparkasse Bank and our media supporters, yes, IT МК, Иновативност МК, Startup Macedonia, Pixel, Semos Education, Radio MOV, Metropolis Radio Network, Smart Portal, Brainster и Reborn МК. Now it's time for me to pass the torch to our first speaker. Everybody, please welcome Alex Krupnov, VP of Engineering at Massive Interactive, who will talk about Massive's history as a business, their valuable achievements, challenges, and some customer success stories. He will also cover Massive Axis product evolution and strategic plan for engineering growth worldwide, including Skopje. Alex?
Thank you. Just 1 second. Hi everyone. So yeah, screen is coming up. So thanks a lot for coming. Really very good to see you here. And yes, I would expect this event to be slightly more technical. I am an engineer myself, and I would be more than happy to get into very deep details of what we do as a company and how it shapes our engineering strategy and how it shapes our engineering day-to-day. But I appreciate that the group here may not be interested in specific technology, so that's why today we tried to prepare it in less technically oriented, yet to give you enough understanding of what exactly we do as a company, how we solve these challenges which our customers bring to us, and how we evolve and what is actually we are doing in Skopje and why we are here. So first, I'm going to tell you just a little bit about us as a company, when we started and what we are right now. So actually, as a company, we have been on the market for quite substantial time, over 21 years. We started back in Sydney, and we used to be much more design company than actually technology one, because you can imagine back in the 90s, there was not too much IT as a technology front, and obviously design has been always there. So we start, and the reason I'm telling you that, because it's tightly shaped our technology direction as well. So back in 90s, in terms of design, we've been doing a lot of brochures, DVDs, you name it, like whatever you can get in the poor world before nice technologies. But one very interesting thing we started doing back then, and we actually still do it, that is design of in-flight entertainments. In-flight entertainment is basically what you see in front of you when you fly over the ocean. It offers you music, it offers you video, and obviously all the airplane-related entertainments, and that's what we started doing back in the 90s, and we've been successful. If you look at our website, probably the most of customer names you've seen, you will see there, in terms of the ones you know, would be about airliners. So we never did any technology for these guys whatsoever, because it's a very, very, very tight and tough industry to get into. It's basically occupied by few hardware vendors. But it's really shaped us as a technology company, and we got this understanding that online video is extremely interesting industry to be in, and basically in past 10 years, that has been our main focus. So yeah, if I am asked by anyone who is not familiar with Massive what we do, I always say that we build applications, because that's what we've been doing for past 11 years. And that's what we are known for, apart from our design business, of course. So we know how to build applications on any possible device. We've been with the evolution of hardware, evolution of software. We know it soup to nuts. But we definitely are going far beyond that. So our product, which we integrate to our customers, is consisting of all the possible parts of your standard software solution. So there is obviously native applications, and by native I mean they're built for specific platform. They feel native, they feel sleek, and they feel vital. But there is also a backend which powers that. There is also all the things related to monetizing it, and you name it. As a company, we never do streaming. That's one of the biggest misconceptions about companies who are in our industry. We never do streaming itself, and the reason is that it requires probably size of the company 3 times bigger than us, and we are about 250 experts globally, and it's basically a completely different business, which one day we may get into. But basically, applications is our bread and butter, and you can think of these apps as basically the way for people to compete to big players. And you may very well ask, what about Netflix? What about Hulu? How exactly your customers even try to compete to such a big players which are available globally, and basically for, I don't know, $10 a month, you can watch anything you want. And there are multiple reasons. And that's why I want to tell you a little bit about our clients, and that would actually allow you to understand what exactly the projects we build. So the first group of clients we work with is TV channels, or broadcasters, how we call them. You can think that this is probably the most low-hanging fruit for us, because they already have user base. They know how to make money of it. Sometimes they don't even bother to sell you anything, because they show you the advertisements, and that's basically, just like on a classical TV, you actually get basically their money in. However, the main sort of way for them to compete to big players is that they produce the content themselves. If I talk, let's say, about BBC, we are talking about A+ titles, how they are called. It's Sherlock, it's Doctor Who, it's something which is famous worldwide. You definitely can watch it on some of the Netflixes and whatnot, but definitely they own it, and they have full right to resell it. But at the same time, if you speak about clients like Channel 5 in UK, these guys are famous for completely different content, which you may be embarrassed to admit you are watching, but everyone does. It's reality shows, it's cooking channels, it's talent shows and whatnot. And it basically has a lot of users to watch. For us, obviously, it brings the challenges of making this experience fit them all, and making sure that we scale with all these people. We also worked with quite a few channels, TV channels in Australia, such as Channel 7 or Channel 9 or VRT in Belgium, but this is basically the TV channel ones. So another one is actually even more close to each of us. In every single country, telecommunication providers, they do exact same thing to their loyal user base. The moment you get an internet package from them, or the moment you get a mobile plan, they try to sell you either a small box to watch your TV, or they try to sell you an application to do it. And the reason is mainly because they kind of invested a lot of money to get a cable into your living room. It's a lot of investment and the same way to get into your pocket. So they want to use all this infrastructure which basically is already available for them. And that's why they, in terms of content, they're not really doing anything different than Netflix or Hulu or Amazon Video, but they want to upsell it to existing user base. So basically, you have no way to go, right? Someone offers you $5 a month for a smaller piece of content. It's basically no-brainer compared to Netflix. And we actually worked with quite recognizable names like Deutsche Telekom. We've done a lot of TV apps for them. Or Bell Media. Bell Media is one of the biggest telco providers in Canada. And they started with the model I just explained to you, but now they actually offer you to subscribe with your credit card. So they slowly become #1 competitor to Netflix in Canada, which is not the biggest country in terms of population, but it is surely a success for our project teams who deliver this app for them. And third group of customers, honestly, it can be anyone else you can imagine. Sometimes we work with extremely exotic customers like Comic-Con. If you heard of them, it's basically a yearly convention when people dress like movie characters or game characters and socialize. Apparently, it's a multi-million-dollar business. So for these guys, what we've built is an application which they call Comic-Con basically 24/7. They make a content themselves, which is very specific to the target audience of theirs, to geeks, movie lovers, and so on. And they have their own user base which watches it. So another example, don't really have to compete to Netflix at all because there is zero intersection. Or sometimes it can be very thematic channels like Animax, which we launched surprisingly in Japan itself. So Animax is a brand owned by Sony Pictures Television. It's all about anime, and basically it's very specific, very targeted type of content. Yet they want exactly the same user experience you can see from a Netflix competitor, and basically that's what we've done for them. Or one of our biggest clients is a company called Perform Group, which actually doesn't even try to compete to Netflix. They are so ambitious, they want to build Netflix of their own. So for that, they launched a product called DAZN, which you can see here. And basically, DAZN is the way they want live sports to look maybe in next 5 years. You basically have exact same model as your typical Netflix app. You pay a fixed amount of money a month, and you watch any sports which is available there. And you can imagine that this is a lot of money, and applications themselves are not probably the biggest spending they have. To give you a sense of the scale of this application is that in Germany, there is no other way to watch English Premier League unless you have a DAZN subscription. And that is application which is built by Massive, and that is actually the scale of their ambitions. So we launched them in all the German-speaking countries. There's not so many of them. In Japan, in Canada, and they keep expanding, and we keep working with them as a primary customer and partner as well. Yeah, so moving on. So how we are different to your standard employer here, right? Or your standard application developer. So first of all, we are an engineering company, which means that all the culture we have, all the processes we have are built by engineers. It's not that you basically have been in marketing and then you started having an IT team and you try to apply all your practices, or you've been in journalism, or you've been in banking. We are purely engineering company, which basically comes with all the benefits of it and sometimes with all the hiccups you can imagine from being an engineering company. Another thing which I already mentioned, we are a product company. So for any engineer, one of the most important things, well, I've been an engineer myself, okay. I cannot speak for all of you, for all of us, but still, it is very important that your work is not thrown away after you finish it. And you can get a sense of it if you are working on projects. So in our case, that's completely different. What we do is based on the products. So the best findings of our projects, the best know-how we introduce, we always get it back to the product, and that's how it actually becomes apologies, and how it becomes reusable for the future. So we constantly grow, which means that we provide a lot of opportunity. And it's obviously opportunity for us as a business, but it's mainly opportunity for people to grow at Massive. And when Massive grows, there is basically opportunity for you to grow. And definitely the aiming for top talent has been the main focus for us, because we want to believe that the teams we have are extremely efficient and extremely successful, and for that we need a top talent. So when I say we make talent top as well, it means that now we are on a point where we can actually implement all these practices and mentor all the people who are more junior for our matters and basically become top talent themselves. So that's engineering culture of Massive, and it shouldn't be undervalued. All right. So a little bit about the engineering organization, because I represent here the Massive engineering team, and which means that this is a team distributed globally across all, except for New York, across all the major offices at Massive. We have about 150 people globally, and basically we are the people who ultimately bring money into company, because we deliver projects for all these customers I mentioned, and that results in success of us as a company. So we have multiple divisions, and I guess you can imagine that UI development is what we are focusing on. That is a team represented by Philippe here, and UI development has been basically our main focus for so many years. We know how to build devices on all possible, we know how to build UIs on all possible devices. We know all the challenges. We do a lot of native development. Our device fleet practically doesn't fit into our offices. So there is a lot of challenges, and Philippe will give you a sneak peek. This is the biggest team, and definitely this is the most dynamic team, because there are so many technologies, there is no way how you can establish it forever. So backend engineering is the team represented by Andrew here. So by backend, I really mean these APIs which powers our applications. So just like I said, our product is practically end-to-end solution, including this backend. So our backend team, they're focusing on mainly on system integration. So they hide all the complexity of building UIs and make it allowing UI developers really to focus on actual user experience and not bothering with repeating same thing in different languages across all the devices needed for the customer. And the main languages there are slightly easier to list than in case of UI, so we are building mostly .NET and Node.js applications. We also have what we call platform operations. So we are a rather modern company in terms of how we deploy and deliver our applications. So we are based on AWS Cloud. And basically, platform operations is a team which is looking after these cloud solutions, working together with developers closely on provisioning the environments, monitoring the environments, bringing innovation there, making sure things are scaling from really, on some projects, hundreds of users initially to dozens of millions in case of the most successful projects. And these are people who are basically working not only on development, but on actually supporting these things post that. And we also have test engineering, so these are our quality advocates. So these are people who basically responsible for final quality, those who sometimes annoy developers, but those are who are placing their signature before something goes live. So we mainly do device-specific testing, because there are a lot of challenges there, and we have a lot of practices on how we do QA and what is the quality bars we have. This is a team which can constantly invest into innovation and automation of the testing, and again, working closely with developers on understanding how applications architecture look like, how backend application look like, and building tests on top of that. All right, so what is the plan here? Just to reiterate, probably it's an easy one, but it is completely worth mentioning that Skopje and Prague are our main regions of growth. So I'm personally coming from Prague. Our office started about 4 years ago and grown from 3 people to about 90 people now. We have completely equal ambitions for office here, and it's only basically availability of great talent for us what can prevent us from doing that. Another thing which is sometimes raised as a question, I'm not sure if you guys have this concern, but we are not looking for any offshore or nearshore development. This is completely equal engineering offices, just like our London and Prague offices. So there is no such thing as basically better work or worse work, more responsibilities or less ones. It only depends on people who are available to do this work for us. All right. So yeah, definitely all the roles. I only presented you just a sneak peek of what our main focus in engineering, but we're also looking for project managers, business analysts, support people, and whatnot. and all the levels. There is no such thing as not hiring juniors or not hiring too senior people. It's basically everything which is available on our market is available here. And that would be pretty much it. So I hope it wasn't too boring for you before the actual technical part comes and you hear from guys. Thank you.
Well, thank you, Alex, for your detailed insight and giving us a feeling of what it really is like being part of Massive Interactive's family. Next in line tonight is Philippe Elsas, Director of UI Architecture at Massive. With previous employers such as Adobe and Proximity Worldwide, Philippe will share with us all the challenges that Massive overcame when moving to fully native UI development across a remarkable range of devices. Also, he will cover the importance of preserving years' worth of foundation and expertise when changing UI stacks.
Hello. I try to not embarrass myself plugging things in. Starting badly. It's on. All right. So hello. I'm going to talk to you. So the summary was maybe not really accurate, but I'm going to talk to you about how we approach multi-screen UI engineering. So I hope it will all make a lot of sense after we go through that. So first of all, I hope you see what I mean by UI engineering, and you may be surprised how often it is confused with user experience or Photoshop, Illustrator, Sketchwork, and that's not the case. It's all very important, and we are blessed to work with very talented designers. But the work of my team is to deliver the applications, to create, to program, and to give life to the designs. And there is nothing mundane or trivial or simple in that job. It is real software engineering. So my name is Philippe, and I'm the UI architect. And to describe it, I would say that I care about applications that people actually use, applications that are fun and that provide value to the users. I've spent in my career a lot of years making throwaway marketing experiences or boring e-commerce, and I must say that I have built the good kind of apps at Massive in the last 4 years. And as Alex said, starting as a developer and growing with the company, going to this role, driving the UI architecture. So, about what we mean by multi-screen. So for most people, multi-screen is, all right, you're making the website and the mobile apps. But for us, multi-screen is really everything. It is web, mobile, tablet, smart TVs, the Samsung and LGs, consoles, PlayStation, Xbox, all the small boxes, so Apple TV, Android TV, Fire TV, basically every device that can run video on demand, because this is our business. We're creating these applications for people. So I suppose you can start to see, if you have any sensibility with engineering, you could try to imagine, how do we develop for all these devices? This is our real challenge. Imagine all the stacks. So yes, our developers get really out of their comfort zone, but we have built a strong expertise and reusable code for all the development stacks that we need to use to target all these devices. So it's very important to say that we don't have people that do everything. All our developers are experts, usually in a single platform. It requires dedication and experience to be very good on one platform. And this is a project team, if you see the screen. This is kind of a project team. You will have, for each project, experts on each of the platforms that we need to target. Not all the projects target all the platforms, but we will be able to align specialists for everything that we need to support. And it goes without saying that our teams are cross-functional. So we're talking about a project manager, UX and design, business analyst, QA. It is always a very complete team working together to deliver the project. So what do these stacks look like? How many of them do we have? So the first one is the web stack, good old JavaScript HTML5. It is very versatile, and it's not just the browser. It is web/TV, because all the smart TVs and, as a matter of fact, all the consoles use HTML5 for the applications. So we need we need to work across all these platforms, across responsive web and those. So what we do is we do obviously JavaScript, but JavaScript with types. And this is for us very important. This is, I would say, in the DNA of the company. Even before TypeScript got popular, we were doing previously other languages that compiled, that were strictly typed and compiled to JavaScript. To simplify, we want proven code integrity in our code base. We want that to be easy for any developer to join, contribute. We don't want spaghetti code. We don't want difficulties in maintaining and refactoring applications. And especially as we need to reuse code between projects, because we need to build up this expertise and this experience. For the view layer, mostly React. It's nice and simple. On the data layer, we like to use Redux lately. One of the nice things with Redux is how it is designed to have a very good separation of the view and the code, the view and the models. And also, Redux works very well for server-side rendering. So server-side rendering, for those who may have heard of it, it's kind of the holy grail of web applications. It is the fact that you can serve. It is a bit ridiculous, because that's how web applications were before they become all dynamic and all JavaScripty and all single-page applications. So we want to be able to serve a static HTML page fast to the user, and then the dynamic application takes over and takes the control of the rest of the experience. And this is a really hard problem, because you have to create two applications. One client-side application that runs in the browser, and one server-side Node.js application that runs on the server. And they have to share as much code as possible, and they have to have a great code integrity. Every time you change something, everything still has to work. Docker deployment. This is what we now add on the web. So we use Docker a lot for serving our Node.js applications. So iOS stack, the Apple stack, iOS, tvOS. So tvOS is Apple TV. So I think as a company, we provide a unique opportunity for iOS developers. No? Closer. Okay. I think we provide a unique... Oh. I think we provide a unique opportunity to iOS developers. It's not just your random social application. You will really work on, for real, on mobile, tablet, and TVs. Generally, it's a fairly standard stack and patterns, so it's all Swift 3, UIKit. The approach we have is to reuse code and is to share the architecture, so knowledge between the two platforms will be maintained, and so the service layer and the general architecture will be shared. Generally, we kind of into reactive programming, and we're using right now Bright Futures, but it's kind of a subset of RX Swift, so I think the team is going to switch to the real thing. So you want to live on the edge, this is where you want to be. So the Android stack now, we'll end quickly about the stacks. So the Android stack is, huge. It is web, mobile, Android TVs, the boxes like Fire TV. We do all of them, and again, it's for an Android developers, it's really a lot of variety and occasions to work on devices that you don't normally work on. And lately, we've been even evaluating the creation of completely custom Android TV launchers, which is a whole other topic, very advanced, very interesting for the team. So generally, we work in Java, but everybody is on the starting block to learn Kotlin. If you have followed a bit what happens on Android world, this is kind of Android's Swift, like the fancy new functional language, and everybody wants to do it. For the rest, common libraries, practices, and RX Java, which is already very well installed in the Android community. And I have a last one, which is the odd one, and I need to show a picture to show what it looks like. It's Roku Box. It is a really odd little box that is dedicated to video streaming. And it's a challenging device to work with. It has it's a collection of box and sticks, and some are really slow, so you have to be really a very good coder and really smart in optimizing. And why does it matter? Well, it matters because it is literally, even in 2017, the most popular box in the US, way above Apple TV or Android TV or Fire TV. So what is it like? It's a lot of weird, it's sort of weird scripting language that exists nowhere else. It looks a bit like Lua. It has quite modern features like multi-threading, declarative UIs, data binding. It's both very modern and challenging to get things fast. Some things are really fast, some things get very slow. It's really interesting. And it's a very small developer community, so we don't find anyone that is, oh, I'm an experienced Roku developer. This is something that you learn because you have your opportunity to learn a really original and unique platform. This is kind of for the, and even the kind of people you have on Roku is all the kind of developers that really think different. They are not just, oh, I'm just going to go mainstream doing iOS or Android or that. They want to do something that is completely different. But right, that's enough stacks. So the stacks, working with many stacks is one thing, but the additional challenge is that our applications are far from being your average complexity. Our applications are fully dynamic, and they are driven by data, rules, and templates. They have to accommodate for a huge amount of combinations. And where does this data come from? So it comes from our CMS, which is the heart of our platform. And this is a tool that provides, again, it's not your average CMS. It's a data modeling tool where you can create the information architecture of the application. And we can segment and structure that depending on device. We can make the structure for TV, for iOS, or mobile in general. We can make it for Roku. We can then segment depending on the user, whether he's anonymous, signed in, registered, but not yet a subscriber. We can also literally segment based on the time of the day or the day of the week. So you can imagine that applications have to accommodate with an enormous amount of rules, and as much as possible, we try to keep all the logic and the complexity on the back end, but there's always things that need to be implemented in the application. So this is a really nice, hard problem to do. And many stacks, complex applications. We need the right engineering practice to handle that. And for us, the key, in our day-to-day work, is automation. So for us, as much as possible, as far and wide we can go, we need to automate things. We need to avoid manual input, tweaks and modifications. It's not like apps are templated. They are not templated. Everything is completely custom. But in the two big areas of automation, there's the how do we create and consume web services. This is repetitive code. The things will be common on project to project. So what we do is, on the back end, we try to use OpenAPI, the artist formerly known as Swagger, that allows us to define and specify our APIs. It also allows us to test them before it's even used by the applications. And the good thing with OpenAPI is that it's a formal way to define services. And once you have something that is formal, you can build the tools that allow the automation. And that's what we do. We automate the generation of the API layer of the application. We will generate TypeScript code, Swift code, Java code, and whatnot, all the stacks that are needed, so that there is, every time you make changes, add new services, change the models, we will generate the server calls, we will generate the value objects, all the shapes of the methods and the responses. This is extremely important to avoid, endless manipulations every time there's an update, human error risks. And the other key of our work is that we automate as much as possible our engineering process. So what we do is that everything is interconnected. From the very beginning of your feature branch as a developer to the delivery of the application to the client, it all goes through the cloud, number of servers that will run continuously, which is the CI, the continuous integration. They will pick the pull request, run the build, run the test, report back that everything is fine. And when we look at, say, Jira, I can say, okay, this Jira ticket, a branch has been created, X number of commits have been pushed to the branch, the pull request has been created, it is still open, it's not yet merged, or is it merged? And we know whether the build succeeds, and we know whether everything's fine, and we can go ahead. And the other thing we do is that it also provides to QA builds ready to test. So everything automated. You don't want a developer to run a build locally, zip it, and send to QA to run some tests. So it has to be fully automated. And likewise, finally, when we want to release an application, we will run a task. We will run a build plan that's going to take the code, tag the version, run the build, run the test, and push to the next phase for the release. which is a store, or it is the pre-production pre-production environments. So I think that gives the overview of how things are. It's a lot of lot of secrets, a lot of experience, building reusability, and yeah, that's all.
I understood everything. Yeah, that was great. Thank you, Philippe. Before we move to our third and last speaker for tonight, I want you just to remember that we are still having this hashtag open, InTechX, for all of your questions, remarks, or anything you want to add up, because as I previously mentioned, we will have a Q&A session after our third speaker is done for tonight. So our last but not least speaker for tonight is Andrew Kazirevich, Principal Architect at Massive Interactive. He is going to try and bust the myths about .NET development being behind the modern programming languages and stacks. Prepare to have your minds blown as Andrew walks us through the world of Docker containers, Linux deployments, and Amazon Web Services internals entirely powered by .NET Core. Andrew, the stage is yours. Oh, I lost you. Applause, applause, applause. Yes, thank you.
Hey everyone. It's very nice to see the whole room, the full room. Thanks for coming. My name is Andrew, and I will talk today about the bleeding edge of .NET development, which is the latest and greatest things which are going on in .NET world lately, and about our adoption of this innovation in here at Massive. So a few words about myself. I'm principal architect, and my daily job is to design and oversee the implementation on various projects that we run on the backend side of things, and at the same time to look into various pain points that we have across the projects and provide solutions so that potentially multiple projects can benefit from the improvements. So before I actually start, let me preface this with a little story. Software development story, which you probably know from your childhood. And it's a story of three little architects. And the story goes as such that once upon a time, there were three little architects, and they decided to build a system. So the first architect, he built a monolith backend service with a single database. It was very quick, and he went away to sing and dance. And then the second guy said, oh, well, it will not cut, so he built a web farm with multiple backends and a load balancer on top of that, and replicate a database, and still it was very quick, so he went away to sing and dance. And the third architect, he was like really tough guy. He said, no, I will build a robust system with auto-scaling, with a failover support, with monitoring, centralized logging, all those bells and whistles. And actually, if you talk about microservices, they are not really bells and whistles. They're indispensable part of your solution, because if you don't invest into infrastructure, then and then if you have a production incident, then you're essentially blind. You cannot really go and visit every single of 40 machines to check the logs or to check the health of those machines. So this guy worked the whole day. And the system was completed, and then the real world came over, as it usually happens. So you ship an app, and your users can come over to visit you. And the first app, it couldn't handle the load and just collapsed, so the architect had to flee. And the second app, it was kind of okay. It was working, but it was difficult to refactor and understand the whole system, and it could not evolve fast enough, which may or may not be a problem depending on your users, because if your users are highly demanding, and that's what really happens these days, that maybe yesterday the users were fine with your app, but today they need real-time updates, they need exports in different formats and so on, and maybe it's a small change in your application, but your components are so deeply interrelated that you really, to make a small change, you need to rewrite half of the system. So this is the problem with the second application. So you need to really, if you want to keep up with the expectations from your users, you really kind of move into this third camp, which is the microservices, and that was easy to develop and maintain because every service is an isolated piece of code, and potentially you can concentrate on the component itself, and it improves fault isolation because if your component fails, then hopefully your orchestrator will automatically restart a new one. And most importantly, it eliminates your commitment to any specific technical stack. What I mean by that is that maybe your system is written in a new shiny language, which was shiny yesterday, but today there is a newer and more shiny language, and you cannot really innovate and adapt this language because you have to sort of rewrite the system. You don't have bandwidth for that. So with microservices, you can really start small and rewrite a single microservice. And one of the definitions of microservice is that it's something that could be rewritten in 2 weeks. So this really paves the way for innovation and adoption, the latest technologies. And before I kind of delve deeper into that topic, I wanted to revisit this quote of Martin Fowler, who is like a very renowned figure in software development. It's the guy who popularized the term dependency injection and refactoring. So what he said about the microservices, he said, don't even consider microservices unless you have a system too complex to manage as a monolith. And like, I don't know how many developers are here in this room. Can you like raise your hands? Yeah, it's kind of half. So probably most of us are in this camp that we have a monolith application, and it may be manageable, or you may face those issues that you really want to innovate, but you cannot afford to rewrite in the whole system for that. So maybe at that point there is time to look into microservices, but the opposite is not true. You don't want to start building microservices from the get-go, because you may find out that you build multiple microservices, but they're too chatty. The communication between them is too chatty, and that indicates that they should have been a single microservice in the beginning. So if you want to avoid those problems, so you start with a monolith and then you break them down. So what we do in Massive for that, we use .NET Core, which is the next generation of .NET, and it's open source, so everything is on GitHub. You can make pull requests, you can open issues, you can watch how it evolves. It's very fast, and most importantly for us, it runs on Linux in Docker, so that we can really run our microservices, which are written in .NET, run on Linux on very cheap machines, so that we actually also cut costs for our clients. And for Docker, how many people are into Docker? How many people know about Docker? Okay, cool. So essentially, this is the next step of your virtual machine. So it's like a sleek virtual machine, very efficient virtualization, which allows you for fast provisioning. It means you can really do deployments in under a minute, in seconds, and it gives you consistent and repeatable deployment pipelines. So if you need a build which was created like half a year ago, you just go and you build it again because you have all the artifacts in your Docker files. So we use what we do at Massive. We write microservices in .NET Core. We also have microservices written in Node.js, and it depends on the project. We have projects which are solely Node.js, so but I will concentrate on .NET Core. So we write them in .NET Core, build them as Docker images, and we run them in Amazon Cloud, in ECS, which is the orchestrator, which takes care of like provisioning the machines, and we set up auto-scaling rules, and if the load is higher, then basically Amazon will create more machines for us, and if the load is lower, then it will automatically drain. If something fails, then Amazon will restart the container. And we set up this infrastructure automatically using CloudFormation and Terraform. So we use infrastructure as code approach, immutable servers, and this idea that you really don't go and click and set up machines manually in Amazon console. And we monitor with CloudWatch and New Relic. And the reason why we use both is that New Relic is not yet ready for supporting .NET Core to the level we expect it to be. And what we find out that we actually do structured logging into CloudWatch, and structured logging means basically that you don't log the text as it is, but you log a big JSON component, and then you can actually search not just for the text messages, for the values, but you can also search for, you can actually search for the values. So if there is a, like, I don't know, response code 200, then you can actually search for all messages with response code more than 200 or less than 500. So you can make very, very serious logging, and on top of that you can build metrics which will then send out emails if something goes wrong, and build dashboards. So as an example, here is a Geolocation Micro-Service. So some of our projects are open in multiple regions, and what we want to do is, like if someone comes from US and Canada, we display the website to them. But if they come from elsewhere, we display like, please relocate, this website is not available in a country. So we built this dashboard that you see on the screen of the CloudWatch logs that our microservices basically just write to the STD out, so we can see the throughput, the latency, the number of errors, and if this amount of errors goes beyond a certain threshold which we specify, someone will receive an email and immediately investigate. So to recap, we use .NET Core because it's cross-platform and it runs on Linux, so we can basically run the microservices on cheap machines. We use Docker because that's how we want to containerize our applications and move into a microservices world. And we use AWS as an orchestrator. It's kind of gives us this vendor lock-in. So we depend on AWS, but our clients and ourselves, we don't really care at this point. We see the value in building the applications instead of building the pipelines and infrastructure. We are happy with what AWS provides to us. So this is basically it for the .NET bit. Thank you very much.
Okay, guys, their job is done. Now it's your time to fire away with any witty questions, some challenging question, or whatever comes in mind. If you have questions, just raise your hand and some of our colleagues will bring in the mic. So 3, 2, 1, Q&A starts now. Yep, mics. See, I'm handy. Guys, mics. Can you yell? Yeah? Who has the mics? Okay.
Hello? Sorry. Ivica, Solutions Architect on AWS. I want to ask about new container services from AWS with the last reInvent. What about Elastic Kubernetes service? Did you think in the future to use it, or Fargate, possibly.
Yeah. I think you should put it on. Hello? It should have a switch. Yes.
Yeah, so we looked into Kubernetes just to observe what it is. And I think the latest Amazon announcement in reInvent 2017 was that they will support Kubernetes inside AWS. But as I said so far, we want to concentrate on like building the business logic. And if we go with Kubernetes, it means part of our bandwidth will be dedicated to setting up Kubernetes cloud itself. So for now, potentially we may look into Kubernetes if we would want to leave Amazon and like become multi-cloud. But it's something very, very far away. So for now, we just use ECS.
Hi, my name is Boyan Vasilevsky, software developer from Pixel. I want to ask Felipe, how are you progressing on React Native?
So React Native is something that we certainly following, and the thing we have with that is that we believe that it has a bit of lack of maturity still, and we think that it brings as much problems that it solves as solutions. And we've been there in the past where we have used Cordova to package native applications, and essentially, like React Native, the convenience it gives in having a reusable UI is kind of reduced by the highest complexity in integrating native components. So in our business, we have to constantly integrate new video players, new analytics solution, new in-app purchase flows, and this all is very difficult to implement. It has a lot of overhead, and the developers, the native developers don't really like to write these wrappers for a cross-platform UI, and the UI developers don't really know how to develop native components. So it comes with a few problems, but I think we'll probably get at some point to using it. So we're keeping a close eye on it.
Okay, thank you. Any more questions? If there's not live, there is this, where? Oh, sorry.
Can you hear me?
Okay. Yep.
I have a question because you have so many platforms. How do you manage all the projects with deadlines and things like that? Because it's a bit more complex to build this kind of projects, looking from that perspective.
That's a trick question. We have different kind of projects, and for a number of them, we are able to first of all manage the delivery by, as I said, we have a lot of reusable components and reference architectures for the applications, so we don't have to reinvent it. And in the case of TV, for instance, the very high complexities around video players, and we build for that abstractions that avoid us to rediscover or to recode to work around all the problems that this device have. But concretely, sometimes it's you can't do anything with the launch deadlines that the clients have, so you have to negotiate the scope of what is delivered.
Okay. There is a question on our hashtag, Guy Strelitz. Would you like to ask in person, or should I? Thank you. The BBC provides video on demand on iPlayer in the UK. What video on demand opportunities were there for Massive Interactive?
Yeah, definitely. BBC is a public broadcaster in UK, which is absolutely rightly funded by the taxpayers, right? There is no way how you can get an opportunity just like that in United Kingdom. However, there is a department in BBC called BBC Worldwide, which is practically available in every other country and basically acts as a little bit as a propaganda in other countries, but also as a representation of BBC as a business. So our product, which we launched for BBC, is called BreedBox, which is actually a joint venture of BBC itself and the major broadcaster, commercial broadcaster called ITV. So their content jointly is available in the United States as under the brand BreedBox.
And that's not all, because technically the iPlayer only has a 1 month's window. So what you get on iPlayer is very short-lived. BBC sits on, thousands of hours of program that you can literally only buy in DVD bundles through BBC Worldwide. So, and that is really the value that is proposed, is the live streaming of all this historical content.
Thank you. Any more questions? Do I see a hand? I don't see a hand, but if I may ask a question, being more focused on HR myself, Alex, you were talking about what it really feels like working in Massive Interactive. What kind of a career path do you offer, or are you planning to offer in the future?
So in our typical engineering organization, we have all the roles starting from, not interns exactly, even though we are looking into internship programs, but there are also roles starting from junior all the way to engineering lead, which we call basically a person who is responsible for end-to-end delivery of engineering team project. However, there are cross-department opportunities as well. So some of our engineers, when they join and they decide that engineering is not necessarily their cup of tea, there is an opportunity to get into our delivery teams and basically become a project manager or a business analyst or a portfolio manager. And there are also opportunities to go more into creative part of our business, because we still have quite a strong design capability. And people with more sort of visible creative skills, they also move into design roles. But generally, we can offer quite a substantial career path for engineers as such, because there are multiple levels within every role we have. And there are obviously roles to go into management and into technical roles. Like, for example, Philippe's role is more focused on engineering management, and Andrew is going into principal architect direction, which is beyond your typical software engineer, basically focusing on architecture across the projects and across the client jobs.
So horizontally as well as vertically.
Exactly.
Okay, thank you for the answer. Okay, guys, if there are not any more questions, 3, 2, 1. Okay, we lock the Q&A session. Thank you all for being here tonight. Thank you, guys. I really enjoyed it myself. I hope everybody else here did. We are not going home just yet now. The night is still early. We're going to have some networking time, so I invite you all to stay a bit more for some drinks and some chit-chat, and maybe we can prolong the discussion that we just had. Thank you all again.